Okay, we're live.
All right, we're reconvening our hearing on H303, and we're going to welcome Jeremy Rathman from Middlebury, who's also my neighbor.
Thank you very much, committee, for allowing me the time to speak. I very much appreciate it. Madam Chair, how much time would you like me to try to?
Say you have to the noon hour.
Okay, beauty. Then I will try to shoot for about 10, 12 minutes of talking and then some questions. So they gave you a very, very good oversight of what we're doing with our interim strategies for PFAS and what we're doing with our biosolids. And I am here to kind of give you a boots on the ground and tell you how that all applies in real life. So my name is Jeremy Rathman. I am the wastewater superintendent for the town of Middlebury, Vermont. So that means that I manage the wastewater treatment plant and the 20 pump stations and the several miles of gravity sewer and force main that serves Middlebury, Vermont. Middlebury, Vermont has a population of just over 9,000 people. That's what we serve at the wastewater plant. Additionally, we are one of those 20 that actually do take septage in the state of Vermont. And we take septage in a quantity that about equates to 2,500 single family households in any given year. Now, I sent over a couple exhibits ahead of time. I'm not sure if you folks have seen those. One had basically a summary of the testing we do for our EQ biosolids. The other was a snapshot of our data. The individual and detailed numbers are not quite as important. It's more just to get kind of a scale of the issue. So the town of Middlebury, and I'm going to give you the nickel tour, is what's called a SBR treatment plant or a sequencing batch reactor. Essentially, what we are is a giant living machine. As most wastewater treatment plants are. What we do is we take the bacteria and the protozoa and everything that occur in the natural world, and we create an environment that is ideal to get them to break down waste through creating anaerobic, very high in oxygen, and anoxic, very low in oxygen environment. And then we treat, and then we discharge the clean water treated with some UV light to the river. Now, this matters because this is a large portion of why we keep talking about sludge, and this is where the sludge comes from. Any machine is a mass balance equation. Mass in equals mass out. So we have all this stuff in here that's living, that's going to break up all the wastewater as it comes in. We feed it new wastewater, but then we also have to keep pulling this sludge out. And that is our wastewater sludge that we treat as a biosolid. Additionally, we take all of our septage at the plant, 2.5 million gallons a year, and we treat that as a biosolid. And so at the town of Middlebury, what we actually create is we create what they talked about, which is an EQ biosolid. So the way that we create our EQ biosolid is we actually take our sludge and our septage and we blend those together and we aerate those to keep it alive so it doesn't go anoxic and septic. And then we press we use belt filter presses to actually remove the water from that combination of solids, which takes it from 0.7% solids to about 14 to 16% solids. We then take that and we heat treat and lime stabilize. So we run it through a pasteurization process of 35 minutes at 70 degrees Celsius or higher. That's 158 degrees Fahrenheit. We also drive it very, very basic. We run a pH of 12 with the addition of our lime. And that is for what they talked about, which is pathogen reduction and vector attractant reduction. So we keep records on all that as we do that process, with our EQ biosolids. And if we are able to meet the temperature requirement, which is the 30 minutes above, we run it for 35, but the actual requirement is 30 minutes above 70 degrees C or 158 degrees Fahrenheit. And we keep the pH above 12, 2 hours after production, and above 11.5, 24 hours after production, which we all test there. We are then an EQ biosolid. So then we do a bunch of additional testing, which is why I gave you folks this 2-page handout, which shows everything that we test for. So I believe they talked a little bit earlier about that we test for all the heavy metals, cadmium, copper, lead, mercury. We test for nitrogens and potassium and phosphorus because those are the actual agricultural benefits. We test for PCBs. And now, since the interim strategy is in place, we also test for 40 variants of the PFAS. And we test that quarterly in our EQ biosolids. And what we have to do in order to, what we find every quarter as we're filing these reports is that our product that we are actually producing with our EQ biosolids program has a lower PFAS concentration than the background soil level of the state of Vermont. Additionally, we have tested the soils of where ours is land applied, and we have a single source where it's land applied to. Our farmer is Adams Farm up in Panton, Vermont, and they've been taking biosolids from the Middlebury plant for over a decade. And we actually went and tested the soils there where we had been land applying for a very long time, and found that those soil levels were still below the background levels as they presented. So we were still below on those soils where we'd been land applying our product, the levels that had been set with the interim strategy of the state of Vermont. And so just to let you know how well that system is regulated, this inch thick folder is my lab result folder, and this inch and a half thick folder is my reporting folder. Everything is reported to the state of Vermont through the ANR online management system. It's called the residual management system, and it's done just like our discharge permits that are done for all of our water-based. Okay, so that is what we're doing right now, is we're actually producing an EQ biosolid. It's all going to the same place. We're monitoring the product to make sure that our PFAS levels on the product leaving are below the background level of the state of Vermont. And we're also checking the soil to make sure that the soil is below the background level of the state of Vermont. Now, there's always going to be some level of PFAS, as they spoke to earlier. And I think that's the one thing that folks, have to understand. And me being the science geek that I am, I've over the years done plenty of research. And I think what a lot of people don't realize is how long this has been present. Like when they actually started doing the research to identify this, they found it in blood samples as early as 1974, right? So I was born in 1977. There's a pretty good chance there was PFAS in my tissue when I was born. In order to find blood samples that did not have PFAS in it, they actually had to find stuff that was archived when soldiers were going off for the Korean War. So we know it was sometime after then, but that's how far back they had to go to find blood that did not have PFAS in it. So we know we have this issue, and we know we need to deal with this issue. And the reason that I am here is to basically speak to the interim strategy that we're using, which I believe is an effective strategy, and also the effect that if we didn't use the interim strategy and we actually switched to a land apply ban, how that would affect a plant like Middlebury, Vermont. So if you look at the other exhibit I provided, which is kind of a snapshot in time of the Middlebury plant in 2024. So this shows all the flows that we received and treated. We treated 388,420,000 gallons of wastewater. And that is just the town of Middlebury, which is 9,000 people. And we all know what the population of the state of Vermont is. So you can kind of imagine we scale these numbers up when we start looking at the effect this would have on all communities. Now, in order to keep those bioreactors healthy, we had to waste out 17,754,610 gallons of sludge out of those bioreactors in order to keep that mass balance and keep. Additionally, we took in 2,537,250 gallons of septic from surrounding communities. Now, these are all the folks who are not on a municipal wastewater system. This is your standard septic tank and leach fields. So that's a grand total of 20,291,860 gallons of material that had to be dealt with. If you convert that through the dewatering process, that works out to about 4,593 wet tons of material. And that's at about what we dewater to, which is about 14 to 18% solids. Okay. So what would it look like if this ban goes into effect on July 1st? Well, right now, my wastewater budget is $3,172,240.09. The current cost of my biosolids treatment and disposal program is $500,000. That's about what it costs every year. It fluctuates a bit. I can tell you it's going up next year because of the Canadian tariffs and my lime suppliers in Quebec. So all of a sudden, I'm going to start paying a tariff on all my quicklime that I buy for my biostabilization. But if we look at a fairly conservative number for what it would cost to actually landfill, based on the projections we've had in the preliminary engineering report we're having done on our plant upgrade right now, the cost would go to $220 per wet ton to landfill, which means that our biosolids would go from $500,000 a year to over $1 million a year. That would make a total wastewater budget increase of 16% overnight. And my big concern I have many concerns with that, but one of my primary concerns with that is, if resources are finite. And so if we make it so that it is that much more expensive to dispose of our biosolids, we may not necessarily be able to raise all of that in user rates. I don't get to just show up and say I need 16% more money next year. That all has to go before the select board. It has to go before the infrastructure committee, has to go before everybody else. If those numbers are not approved, that means that all that money comes out of, it means it's less testing done in the lab, less quality control done. It's less preventative maintenance that's done on equipment. It's pumps that don't get replaced as often. And we talked about combined sewer overflows. One of the primary causes of combined sewer overflows in the town of Middlebury is when we have pump failures. And so I want everybody to realize that we can't look at this in a vacuum. We can't think that it's just the biosolid impact. It's really a holistic system that we need to look at. And we need to, in my opinion, figure out the best way to manage the concern. And I completely understand the concern that led to the writing of this bill. I mean, I grew up on a dairy farm in this state. I understand wanting to be a steward of the land. It may come as a shock to you folks, but nobody gets into the business of doing what I do for the glamour or the money. You become a wastewater operator because you care about the environment and you're trying to become a steward of the land. And what I'm afraid is if we go down this road, there's going to be unforeseen consequences, not only with the deferred maintenance or the money that we are currently putting into treatment that perhaps has to get pulled out and put into elsewhere to deal with the biosolids, but also the fact that, we have, as the representative stated, limited landfill capacity in the Northeast. And I'm very much concerned about just stopping all testing, as this bill says, and landfilling everything. And the analogy I use, because before I became a wastewater operator, I worked as a mechanical engineer, and I did a lot of old building renovations. And the analogy that came to mind is asbestos, right? Asbestos was a wonder product. We put it in everything. And then we discovered it caused mesothelioma and everything else, and we realized what a problem it is. But when you renovate an old building, you don't encapsulate and put on the safety equipment for every single piece of material you pull out of an old building. You bring a sampling team in and you pull samples and you run lab tests and you figure out what the danger is and you figure out what's safe. And then you take your limited resources and capital and you put it into dealing with what the danger is, which is exactly, in my opinion, what the interim strategy is right now. We're sampling our biosolids for PFAS and these other contaminants. And we are coming up with, we have an interim strategy that we're doing to check not only the product that is leaving our plant, but also the product where this product is being placed on Vermont farms. And we're keeping an eye on that. And I would really like to see the regulators continue their job, because I think it is very, very effective. And I think they've shown through their presentation today that we are, if anything, ahead of the curve. And I'm really, and although I understand the concerns that led to this bill, and I agree it's a problem that need to be solved, I would say as a boots on the ground person who deals with it every day, I just feel there's a better way to solve that problem. And the regulators of the state of Vermont are already working on that better way.
Thank you. Thanks for your testimony. I bet we'll have a bunch of questions. Representative Bartholomew.
So you test quarterly?
Yes.
Doesn't seem often enough, just gut reaction to really know what's in there.
And that could be something that could be discussed with regulators. I would much rather add money to my budget for analysis than completely ban something altogether. But that is what was determined as a testing period. At one point, we were testing monthly, but the samples were all coming back, at least for the Middlebury plant, at very low levels. So we switched to a quarterly testing.
So you were testing more often and didn't find cyclical stuff going on.
Right, exactly. And it's an interesting thing because it's where we store our sludge, where we mix it all together. That is never, it's kind of a never ending thing, right? We never fully empty the tank. The tank always has a volume in it. So you always have residuals of everything that's in there. So it's not like you could, you would not pick up something that was
Not just batches.
It's not a fully batch process because we're always mixing and there's always stuff in there. Yeah.
Can you speak to a little bit about kind of the catchment area of Middlebury? You said a couple times 9,000 residents. Many of us are not on the actual, wastewater line.
Yeah.
Hopefully we're pumping our septic tanks, but how do you decide how much septic you take and how many towns does that come from? Or is there a way of measuring the
So it's,
watershed for it?
so that's a very good point. So I can tell you right now, we take as much as we can. Mainly because there's so few places that will take it. And when places go down, it becomes a big problem. So, we actually had an issue in January where we got a load of bad septage where a fuel oil tank had leaked. And we got fuel oil into our system and we had to do an environmental cleanup, and we were offline after we discovered that for a month to do all the cleanup and everything else. And all of a sudden, all those drivers from our county were driving all the way to Rutland or driving all the way to Shelburne. And so we basically serve, I would say the folks probably north of Ferrisburg are going to Shelburne. The folks south of maybe Pittsford are going to Rutland. We're probably catching most of the folks in between.
Yeah.
Yeah.
And when you say you went down, you still had to treat the treatment,
Well, what we did is we didn't take any septage.
but everything going through the system was treatable.
Well, what it was is we inspect it at the end of the day. And so we did our inspection and found a contaminant, evidence of a contaminant. So we shut the septage down, brought in a testing team, an environmental consultant, tested everything, and then did a cleanup of it. And until it was all cleaned up and certified, we didn't take septage at our plant. And it was a major problem for the septage haulers in our county. They were very upset by the tail end of that.
I guess I'm not understanding. So there's a separate tank for the septic.
Exactly, yes. So we take septage in a complete, so septage receiving is always completely separate. And then, so what it is you take the septage through and it goes through a small unit that takes out like rags and physical items. Then we flow down into a tank. And then from there, we have two places we can put it. We can put it into our solids treatment process, or we can put it into our bioreactors. We always put it into our solids treatment process, because when Bob Wells, who was the superintendent before me, when they built that new plant, for the first few years, they ran it directly into the biological reactors. And what they found is if they got a very strong load of septage, it could set a reactor off and that affects the discharge permit. And so it's much easier to treat it running it through the residuals management permit of the solids treatment process than it is to try to keep a bioreactor happy if it doesn't know what it's getting fed. Yep.
Further questions? Thank you so much for joining us today and for your testimony.
Oh, thank you very much. Thank you so much for the time.
Thank you.
Thanks, Jared.
All right, members, we are, I think we're due for a short floor today, and I don't know, Matt. Stay tuned. I need to figure out if we do want to or need to talk about Bottleville PRO. That was what we missed this morning on our agenda. So right now we're not scheduled for this afternoon, but check your emails.